So, today we are covering patterns, number patterns, with a focus on quadratic number patterns. Now, as I understand it, you guys have already started with number patterns, and today is mainly just practice. So we're going to be focusing on practice. I hope you guys have your calculators there with you, because I, in fact, do not have mine. I left it at work. So please get your calculators, get your pens and your paper, and let's get started. Okay. So first we have an example, which I am still going to ask you guys to work through with me. And as you know, I do them beforehand so that I don't get, if I don't prep them, I do it before so that I don't seem lost and confused when I'm in the class. So, okay, so for the following sequence, find the equation for the general term and then use that equation to find term number 100. All right, so first thing is we have to look for the general term and use that to find term 100. Now, before we get started, I'm just going to write on the side here what's the general term, what we use to find the general term, and that would be a n squared plus bn plus c, or your constant. So this is what we're going to be working with, which means obviously we have to find a and b and c. Okay, so firstly, let's look at our number patterns, or number pattern. And we need to find our first and second differences. In a test, you would generally do this to check what type of number pattern it is, okay? You cannot just assume it's an arithmetic number pattern or it's a quadratic number pattern, but working out the differences will tell you what type of number pattern you're working with here. So let's look. So from 4 to 7, what is my difference? 4 to 7. So I'm going to ask you to put a plus or a minus and then the number that I am adding or subtracting. Okay, Edith, that's fine. You already put it there. So first we add 3 and then 7 to 12. This pen is way too big. It's not going to fit here. So we have a plus 3 for our first two terms. What about between term 2 and 3? Thank you. That would be a plus 5. Term 3 and 4. That would be a plus 7. We can see a trend here. And the last one, term 4 to 5, is plus 9. Thank you. So we can see it is not an arithmetic number pattern because our difference is not constant. All right, we have a difference, but it is not the same. There we go. Okay, let's find our second differences. Second differences for all of them, as we can see, is just 2. So this is indeed a quadratic number pattern. And let's fill in the information that we have found. Tell me something about the second difference over here. What is it equal to? Your second difference, we're going to write 3 many pieces of information over here. Our second difference is always equal to, in relation to these 3 variables that we're looking for here. That's a hint that I am giving you what I'm actually looking for. Thank you very much, Edith. Our second difference is equal to 2 times a. So 2a is equal to the second difference. In this case, that is 2. Let's just work out a while we're here. Divide by 2 on both sides. That means a is 1. Okay, we're done with that. Let's do our second mini working out or equation. What is my first difference equal to? The first difference. These are all first differences, but I'm talking about the first one specifically. In this case, that is plus 3. What is that equal to? Our first difference is equal to, does anybody know? It is equal to 3a plus b, guys. So we need to learn that, okay? Second difference equals to 2a. First difference is equal to 3a plus b. And what is our first term equal to? Let's see if you guys know this. You should know this. Our first term would be equal to what? Let me write it over here. Our third mini working out. First term is equal to A plus B plus C. Okay, so make a little information sheet, information board for yourself there so that you know all of this information. I'll make a little note on the side in case someone wants to take a screenshot after this, but for now let's work it out. So we have 3A plus B is equal to 3, which is my first difference, but we know A, we just worked it out. What's A again? How much is A again? 3 times 1 plus B is equal to 3. Thank you very much, guys. So that means that B will be equal to 3. That was already on the side. And I am taking my term and taking it over, transposing it. You guys have a lot of words for this. Transpose, inverse operation, and it becomes a minus 3. That means our B is equal to 0. 3 minus 3 is 0. What does that mean for my second part of this general term? You need to be thinking ahead now. What does that mean for my second part of this general term? If B is 0, what's going to happen with that whole second term of my general formula? Come, let's chat, guys. Let's just practice today. If you're not sure, say you're not sure, but say something. What happens to B? It's going to just fall away, right? Because then it'll be 0 times n. So your whole, nice, Atlechang and Edith. So the whole middle term will just fall away. And then, of course, finally, A plus B plus C is equal to the first term. And in this case, that is 4. We already know A. We already know B. So let's work out C. Okay, A was 1 plus B, which was 0, plus C equals 4. Okay, that means C is equal to 4 minus 1. Therefore, C is 3. Now, we have found all 3 variables in my general formula. That means Tn will then equals 1n squared. Do we have to write the 1? Do we generally write the 1? I mean, you can, but not generally, okay? So it's n squared. We spoke about the middle term, which falls completely away because B is 0, okay? B is 0. Maybe I should actually write it. I'm going to write everything before someone gets confused. So this would be 0 times n plus C, which is 3. And then you can write the proper one where we leave out the 1. This whole thing is 0, so it's gone, and that's plus 3. Before I move on to finding term 100, can we have a thumbs up, thumbs down on what we just did right now? If you understand, give me one of these, and if you don't, give me one of those thumbs downs, and we can talk about it. Okay, I did not. Renelwe, I did spot a thumbs down. Renelwe, are you comfortable with unmuting? Or Tandiwe? Okay, one of you guys, not both. Are either of you comfortable with unmuting for me? Maybe I should allow you guys to unmute. There we go. Anyone who's comfortable with unmuting between Renelwe and Tandiwe, I believe, please unmute so we can talk about it. Anyone? Tandiwe, there you go. Tandiwe, you can unmute yourself. I have changed the setting.
Hello, ma'am.
Hello.
Ma'am, can you please do another example?
Okay, I am definitely going to do that. But I think before I do that, let me make a little information sheet for us to take a screenshot of. What do you guys think? Let me make a little information sheet so we can take a screenshot. And if you can grasp what just happened, or if you can grasp this info sheet, then you'll grasp everything. Okay, so the general formula for quadratic number patterns is always an squared plus bn plus C. Okay, your T1, whatever your term number 1 is always equal to A plus B plus C. Are we with me? Okay, and now your first, I know this is confusing, but you're going to understand what I'm saying just now. First difference is equal to 3A plus B. Okay, and then last final piece of information is your second difference is equal to 2A. Okay, so take a screenshot of this, please. It will come in handy if this is a little bit confusing for you right now, but we will do another example, don't worry. All right, and Sinako has already done our term 100 for us, okay? While you're all taking down this, I'm going to do term 100 on the side over here. We already found the general formula, which is that one. So it will be n squared, and n is 100 in this case, squared plus 3. What is 100 squared? That's 10,000. So it's 10,003. 10,003. There we go. Okay, let me zoom out in case someone wants to take a screenshot of this whole question. And then I will follow the request for another example. Okay. Okay, let's look. For the following sequence, again, we are finding the equation of the general term and then finding term 100. So let's put our information sheet into good use. This time, I'm going to say let's start with the differences. Okay, just to make things easier. Let's start with our first differences. Term 1 to term 2. What is my first difference there? Term 1 to term 2. Term 1 to term 2. Thank you. We're adding 6. Okay. Term 2 to 3. Term 2 to 3. That wasn't the question. We're adding 6. Thank you. Term 3 to 4. Butle has a question. Screen keeps falling away. Is anybody else having the same problem? Anyone else? No. Okay, it might be settings on your side. It might be settings on your side, Butle. Okay, try to go to settings and change the view, baby. That might help. Okay, you can exit and rejoin. Okay. Okay, so we're adding 6, and we've established that this is indeed a linear or arithmetic number pattern. Okay, well, now the rules have changed, but don't worry, we're going to do another examples of the other one. Does anyone remember what the general formula for finding a linear sequence is? Tn equals. Anyone? I'm going to wait for a few seconds because I think someone might remember. Bn plus C is one you should have been using in grade 8 and 9. Which one do we use generally in FET? It's not wrong. Okay, it's not wrong. But which one do we generally use in the FET, guys? I'm going to wait for an answer. Do you have any idea? Thank you very much, Matidi. So that is A plus N minus 1 times D. What does the A stand for? This is your first term. And D is the constant difference. Please be careful with unmuting. Let me block it since nobody is speaking to me right now. That's okay. Okay, so then we're just going to substitute, right? This is simple and straightforward. My first term in this case is a 2 plus n minus 1, and our constant difference is a positive 6. So I put positive 6 over there. Now, don't leave it like this. Please simplify always. All right, so I'm going to distribute the 6. I'm going to distribute the 6. 2 plus 6n minus 6. And if you're confused about where I get that minus 6, I just times negative 1 with positive 6. Okay. Then we have our like terms, which is the 2 and the negative 6. So 6n minus 4, because 2 minus 6 is 4. Okay, let me see. It is a formula for grade 12. I guess different schools have different rules. In our school, we're not allowed to use it we're not allowed to use the other one for FET. So as soon as you get to grade 10, this is what we use. Okay. So I think different schools have different rules probably. But we generally use this one. As soon as they get to grade 10 and up, we use this formula. Okay, and then to find term 100, we just substitute 6 times 100 minus 4, which will give me 600 minus 4. That means T100 is 596. Thumbs up, thumbs down on this one. I have a feeling this one is a little bit less complicated for most of us. But if you don't understand, don't be shy, guys. Just ask. Okay? I'm just going to get to the quadratic one and help us quickly. Okay. And I'm scrolling in the wrong place. There. Okay. Well, the following sequence, again, general term, then use it to find term 100. First, differences. Let's hear. 7 to 13. Excuse me. 7 to 13. Thank you, Edith. 6. And then term 2 to term 3. We added 10. And then we added is that 19? Check again. 23 to 37. Oh, there's a lot going on here. We added 14. Okay? 14. And then 37 to 55. Yes, but we need to follow one another. Okay, when we run there and some of us are still here and some of us are, that's confusing. Okay, so we can't all answer 18 when I haven't gotten the answer for 14. Okay, we need to be on the same page. Now let's look for our second differences, which I'm pretty sure are the same, and you can already see. What's my second difference? My second difference is 4. Okay, 4, 4, 4. Great. Now let's get back to what I was saying. Okay, so we know that we need to find Tn, which is an squared plus bn plus c. And my squared could look a little bit better. Great. First term, T1, is a plus b plus c. Okay, I'm rewriting that information I told you. The first difference, so I'm going to just write first, comma, first. You guys know what I mean when I say the first difference, is equal to 3a plus b. And the second difference is 2a. I've written all the information down. Great. What is the second difference? What is our second difference over here? Thank you, Edith. So 2a is equal to 4, which means I can find a. I'm going to divide both sides by 2 to get a on its own. Okay, these will cancel out. That means a is equal to 2. Great. Now you might be asking why we start at the bottom. That's because the one with 2a is the only one that has one variable. Do you guys see that? Rather stick to the one with one variable, and then you use that answer to work out the second one with 2 variables, and you use that answer to work out the final one with 3 variables. All right, guys. Great. Now we have A, which means we can now work out B. What is my first difference? My first difference. Nice, Edith. Okay, so my first difference is indeed 6. That means 3a plus b is equal to 6. But we know a is 2 because we just worked it out. So 3 times 2 plus b is equal to 6. 3 times 2 is just 6 as well. These b's and 6's are starting to look like the same thing. My eyesight... I'm going to take the 6 over, and that's going to give me b is equal to what? 0. Lovely, lovely. Great. Now we have B. So far we have A and B. We need C. Term 1 is equal to A plus B plus C. Term 1 in our case. All right, just so long. Thank you very much, Ganlin. Is equal to 7. We know A is 2, B is 0, and C, that's all equal to 7. So C will then equal 7 minus 2. The 0 is just gone. That means C is 5. So my general formula is A 2n squared. B is 0. What happens to the whole middle term if B is 0? My whole middle term falls away. Thank you. And then plus C, which is 5. Now let's look for term 100. This will be 2 times 100 squared plus 5. So that's 2 times 10,000. So that's 20,000 plus 5, which means 20,005. 0, 0, 0. Yes. All right. Specifically, the 2 people who did not understand the previous, are we good? Is everyone good? Renelwe, I see you raise the hand. Is everyone good? Thumbs up, thumbs down. Renelwe, you may unmute.
Hi, ma'am.
Hello.
I just wanted to ask, when figuring out C, where did the 7 come from? And what do you mean by the first difference?
Okay, so I'm going to first deal with the first question. Where did the 7 come from, right? So A plus B plus C is always equal to the first term. What is my first term of my number pattern here?
Oh, okay.
Or my sequence? It's 7. Do you see?
Mm-hmm.
So whatever is in that first position will be equal to A plus B plus C. Are we good with that one?
Yeah.
And then my first difference, this is what I mean, okay? Do you agree that these are all first differences?
Yeah.
But I don't want to deal with the rest of them. I want the first one, as in the difference between term 2 and term 1.
Oh, the first. Okay, thank you.
Yes. So the first difference. So I don't want to say first difference because that would mean all of these in this row. I mean the first difference. Make sense?
Okay, thank you so much.
You're welcome. Okay. Hopefully you guys are all good. We all understand. Those were 2 good questions. So I hope everybody is good. Okay, I'm tired of finding Yeah. Okay, let's do another example. Okay, a certain quadratic pattern is given by Tn is equal to negative 2n squared plus bn plus c. Find the values of b and c if the sequence starts with this terms. You actually didn't even need the value of a because you can work it out, just using this. Okay, let's find our first differences. Now be careful because these are negative numbers. So between term 1 and term 2, let me move this here so I can see you guys' answers. What is my first difference between term 1 and term 2? Nice, Scanlon. We are indeed subtracting 9. That's why I said be careful of negative numbers. This is subtracting 9. Okay, what is my second first difference? Second first difference. Nice, subtracting 13. And what is my third first difference? English is tapping out now. Third first difference. 17 minus 17. Great. Let's look for our second difference quickly. Our second difference, negative 9 to negative 13. That is a difference of how much? 4. Thank you. Negative 4, negative 4. Great. We don't have to do the whole 2a story because they already told us what a is. Okay, it's in the formula. It's there. A is over there. But we can say 3a plus b is equal to what? 3a plus b is equal to what? Negative 9. Nice, Edith, because that's my first difference. We know a is negative 2, so 3 times negative 2 plus b is equal to negative 9, which means negative 6 plus b is negative 9. Take my negative 6 over. Tell me what b is, guys. Let's hear what b is. Nope, be careful. Yes, Kawe, it is negative 3. We're done with b. And then, finally, we know a plus b plus c is equal to what? A plus b plus c. What would that be equal to? Negative 6, because it is my first term. Lovely, guys. You guys got this in the bag. Okay, so a, negative 2. You can still do the plus minus thing, but you know it's going to become a minus, right? Hopefully. Negative 3 plus c is equal to negative 6. So that means c is equal to negative 6 plus 5. How much is c? Negative 1. Lovely. Okay, it sounds like you guys are a lot more comfortable now. We're having a lot of answers in the chat. Thank you very much. Love it. Screenshots, are we good? Can we move on? Nice. Thanks, Edith. It says problem pairs and then there's a gap. Oof. Okay. A quadratic sequence has this formula. Okay, so I did an example. You guys are doing an example now. That's how it goes. Okay, Tn is n squared plus Bn plus C. Determine the values of B and C given the following sequence. Okay, I'm going to go ahead and start with the differences, but I want to say something about that general formula they gave us. 0 to 4. 0 to 4, what is my difference? A positive 4, so I'm going to write plus 4 here. 4 to 10, what is my difference? 6, and finally 10 to 18. That would be 8. Great. So what is my second difference? I'm pretty sure you guys can see it already. positive 2. Great. Now, do we need to work out a in this case? Do we need to work out a in this case? Anyone? Why not? Why not? It's 1. Thank you. It is 1, okay? If there was no a, they would have written a n squared. But there's no a, so that means a is 1. That was horrible, but you guys get the point, okay? So we know that a is 1. So let's go ahead and work these out. I'm going to start off by working out b by saying 3a plus b is equal to, what is my first difference? 4. Okay, so 3 times 1 plus b is equal to 4. You can actually even solve this by inspection, but let's be technical. Let's be technical. That means b is equal to 1 because it's 4 minus 3. Great. And then a plus b plus c is equal to term 1, which is 0 in this case. So 1 for a plus 1 for b plus c is equal to 0. This can also be solved by inspection, but let's do the whole working out. Matiriso has solved it by inspection. Is 0 minus 1 minus 1. That means C is negative 2. I think this is pretty simple and straightforward. I think this is all good. Okay. Oh, you guys have a brain break. Isn't that interesting? Let's see who can solve this the fastest. Brain break. That means your brains are taking a little bit of a break. I can't believe I actually explained that. Like, you guys don't know what a brain break is. Green bird is 4. That is true. 4. After that, it gets a little bit murky. Just a little bit, though. I'm pretty sure you guys can figure it out. Anyone know where to go after that? See what I meant? It gets a little blurry. Anyone? I got murky, Shem. It got murky. Do you guys want a clue of what you're supposed to do here? Simultaneous equations. I know it's a bunch of birds, but it's simultaneous equations. That's the only way I was able to. I didn't solve it, but I looked at it and I was like, seems like simultaneous is the way to go. Okay. So let's give these guys letters. I think green birdie must be G. This guy. Okay. What about other green birdie G's? I already gave away G. This guy will be R for red birdie. Can we do jumping jacks to get black? Sure. Sure, you can do that. You can do that, okay? It's a brain break after all. And this guy, I'm just going to call B, shame. B. Okay, go from there. Callan says 9 plus 4 minus 3 is equal to 10. 9 plus 4 minus, yes, that is true. And 9 divided by 3 is 3. That is true. Callan, do you want to tell us how you got that? How did we get that? I worked backwards. No idea what that means. Just explain to us. Maybe I went about this too complicated, guys. Life is sometimes not that complicated. I'm guessing half the class is doing jumping jacks with Amogelang. Karen, I'm very curious to know how you solve this. Worked backwards. So you have a 4. Okay. Oh, but that makes sense. If you know it's 4, then... Oh, okay. Yeah, I see what you mean. It wasn't that deep, guys. It wasn't that deep. If you know that this guy is 4, but how would you know the other one is 3? Kellen, yeah, I don't know which backwards you're working with. If you guys want to do this on your own, I use simultaneous equations, okay? So I just put a 4 there, and then I ended up with b minus r is 10 minus 4, which is 6. And then you also have b divided by r is 3. And then I worked with that. But yes, Kellen has solved this, guys, which means the final answer is what? We know this is 4, that's 9, this is 3, so it is 4, 7, 16. 16. Well done, Kellen. Is Amkhalang back from jumping jacks so we can continue? Yes? Probably. Okay. Let's go with this guy. We haven't done these ones yet, so I think it's time. Okay, so now we have been given the actual general term or formula, okay? And they want to know for which value of n, or for which place or position in the sequence, will Tn be negative 394. Okay, so obviously we would have to start off by substituting 300, well, negative 394 into Tn. So let's do that. After that, I want to hear you guys' suggestion about what we're going to do here. Is equal to negative n squared plus 4n plus 2. Let's hear. We have now substituted, okay? We were told that Tn is equal to 394, and we want to solve for n. So where do we go from here? Where do we go from here? Anyone? We make the equation equal to 0. How do we do that? We obviously have to move something if that's going to happen, right? Transpose 2. Take negative 3 and... Ooh, there's a lot going on. Okay. So if I move 2 that way, that's not going to make my equation 0. But I can move this that way. Okay? So then 0 is equal to negative n squared plus 4n plus 2 plus 394. You're going to see the problem just now, but I'm waiting for you guys to see it. While you do that, I'm going to simplify what we have done here. Jeez. Equals 0. Has anyone spotted the problem yet? Okay, let's not talk about the problem. Let's talk about solutions. Now that we have done that, what do you think is going to happen? Buhle. Yes, Buhle. Let me allow Buhle to unmute. Yes, Buhle, I see your hand is up.
Ma'am, wouldn't we need to divide the negative with each of the terms?
You can divide it, but you can just move them all to the other side. So yes, let's divide it throughout. So then we want a positive 1n squared minus 4n minus 396 is equal to 0. Buhle, do you know where we're going after this?
We can use the quadratic formula.
Yes, we can. Okay, let's hear, guys. N equals negative b plus minus square root of b minus 4ac over 2a. Woo! Then we use the positive value as the negative value is not applicable. You are beautiful, Sinako. That is beautiful. Okay, let's substitute. Let's substitute, which is equal to negative 4. Hoping you guys are doing it on your side as well. Minus 4. A is 1. C is negative 396. All over 2 times 1. Great. So this is 4. Okay, now I need a calculator. Now I need a calculator for that whole situation that is under the square root. Okay, so first I'm going to say negative 4 times 396 minus 4. 1580 over 2. Can I have the square root of 1580, please? I don't have my proper calculator here because I am a terrible teacher. Did I do this correctly, guys? Why am I getting such a weird answer? 396? Yep. Yep, that's what I got. Can we have confirmation, please? From the crew? B squared. That's what I did wrong. Thank you. So this is actually 16. Minus 396 times. Great, that makes more sense. So my square root is 40. So it's square root of 1,600. Ooh, which means it's 4 plus or minus 40 over 2. So my 2 would be 44 divided by 2, which is 22, or 36 divided by 2, which is negative 18. But we know this cannot work. So it's not less than 0. It's greater than 0. Therefore, n is 22. So that means the term in position 22 for this specific sequence will be equal to negative 394. Nice, guys. And thank you for your assistance and your calculators, because I don't have mine. Okay, let me fix this before someone takes a screenshot of the wrong thing. Thumbs up, thumbs down. It doesn't work because it's a negative. Remember, we were looking for the position of something. So you need to look at context. Okay, so term number what? You can't say term number negative 18. So it has to be number 22. Okay, I saw your thumbs up, so I'm guessing you're good. Uhle, you can unmute. We can.
Ma'am, I'm not sure, but when I substitute 22 into the formula, the original one, I don't get minus 394. I get 574.
Is that why Amukelang says we may need to check it? Let's check it. Okay, where's my original formula here? There. No, there. Term number 22 is equal to negative 22 squared plus 4 times 22 plus 2 equals negative, what's 22 squared? 22 squared. 484 plus 4 times 22.
Oh wait, it's right. Sorry,
Okay, I see what happened.
I
Did you put the
I put
negative in
the
the
minus
square?
inside the bracket. Yes, ma'am.
Okay. Okay, so we must be careful of our calculators. So we have confirmed that it's right. So negative 484. And it is indeed correct. Okay. Are we happy? Amogelang? Oh, Amogelang already checked it. Okay. Matsidi, so that is true, but you need to look at the context. Okay. We need to look at the context. So this is not like physics where we can go in the opposite direction and say negative just means we went in the other direction. This is, I mean, if we're running a race, you cannot come in position -5, right? You would rather be in lost position than in a negative position. So the answer would work if we were just doing a normal factorization here using the quadratic formula, then yes, they're both valid. They're both valid answers. But because we were asking about the position of something, it has to be the positive answer. Does that make sense? Okay. Okay, and we've done our checks and we reminded ourselves not to square the negative. Okay, I think we can do 1 or 2 more and then call it a day. This one is too simple for you guys. So let's go with this one. Okay, given that 2n squared plus n minus 2, or tn is equal to that, find the value of n such that tn will be equal to 298. We are doing the same thing. Can we have people working on their own? The fastest fingers first. Whoever finds it first, please send it in the chat and let us see. And let's hope I remember what the hell I'm doing here. Plus minus b squared minus 4ac all divided by 2a. Okay, so it's actually a good idea on the side to write for yourself, especially if you're scatterbrained like I am. A is equal to 2, b would be 1, and c is -2, just for peace of mind. Just for peace of mind. Okay, so it'd be -1 plus or minus 1 squared minus 4 times 2 times -2. Now this one looks funky again, but I'm not gonna. Oh no, it's 9. It's 9. It's fine. It's fine. 2 times 2. There we go. So -1 plus minus, that is 4 times 2 is 8, 16. And my brain just switched off. And that is positive. N is 12. Okay, someone has figured it out, but I haven't. How can I be stuck on something so stupid? Okay, we have 1 squared minus 4 times A times C. Right? Am I tripping? Don't tell anyone I use that language. 4 times 2 times 2. 16. So what did you guys find the square root of 17? That doesn't look right. Nobody, okay, let's go to people who already found it. So for this one, we don't subtract. That's what happened. maybe we should call it a day. Peter's gonna fire me after this. Peter is gonna fire me after this. I am fired. Don't tell him I said that. Yes, so C is 300 plus n minus 2. I don't want to make the same mistake, so I forgot to add minus 2. No, what am I doing? What am I doing? Plus n minus 2 minus 298. So it's negative 300. So it's negative 300 actually. This whole situation is minus 300. Now we can do this. That time you guys are watching me make a mistake and we are all quiet. May I see you? But it's fine. We're tired. It's okay. It's the first day of school for me, okay? That is my excuse. We open today. 1 squared minus 4 times 2 times negative 300 all over 2, 2. Snako is like, oh, look, all I'm going to help with is the final answer. I'm not going through all of this that we're going through. That's all Snako's going to do. Like, I'm not finna go through this with y'all. Not finna go through this with y'all. 1 minus 1 plus minus the square root of 1. What's 4 times 300? Even this one looks suspicious, guys. I. Matsidiso also got 12,5. Even this one, I'm suspicious. Let me erase this to make more space. Okay. So what, you guys got the square root of E? I don't have a calculator. Remember? Let's do this. I think cell phones can do that. Yes, they can. There we go. 2401. 2401. The square root of that is 49. Okay, minus 1 plus 49 is 48 divided by 4, or, so let me say, therefore n is equal to this, or n is equal to negative 1 minus negative 50 divided by 4. Therefore, this is indeed 2, 4, 6, 8, 12, or n equals, what's 50 divided by 4? 12,5, which, no. Therefore, I actually have like 5. They're just in my classroom because you learners always forget about them. So they're in my class in case learners want to borrow them.